Hello, welcome to this video 5-2. We are going to talk more optimization, and the example that we're going to look at here focuses on both maximization and minimization. What if a problem is using the same context and asking the same things? Where is it maximized? Where is the function minimized? So let's go ahead and look at that. Just note, if you're reading through the procedures, or if you want the step-by-step approach, look back at 5-1. We're using that same step-by-step procedure, and I'll talk through those as we go through this example. All right, so without further ado, here we go. This example says the sum of two non-negative numbers is 30. Find both numbers if the sum of the twice the first plus the square of the second is a maximum. All right, so let's go ahead. Step one, let's identify our variables. Again, we're talking about two non-negative numbers, so I'll just use x and y again. And the information that they tell us is that the sum of these two non-negative numbers is 30. So x plus y is equal to 30. So what we want to do is we want to, they say, maximize this equation, where they say that the sum, okay, of twice the first number, so 2x plus the square of the second, I don't know why I wrote s, square of the second, I'll use y squared, okay, and they want that to be maximized. We want to maximize that, okay? So what we're going to go ahead and do is I need to rewrite this with one equation. So what I'll do is I'm kind of afraid of that quadratic there with the y, so I'll isolate x. This tells us that x is equal to 30 minus y. So I'll just go ahead and use direct substitution and substitute that in. So I have 2 times 30 minus y plus y squared, and I'll simplify this to give us 60 minus 2y plus y squared. And what I'll do is I'll rewrite this in standard form. Okay, so there is my equation in univariate form, one variable. Okay, so next what I want to do is I want to look at the domain, like what could these numbers possibly be? And remember, we're adding two non-negative numbers, so when they say non-negative, I know that it can not be negative, so 0 or more. And well, I mean, if x is nothing, right, what's the biggest y could be? 30. Okay, so here is my domain. That's step 4. And then what we want to do is we want to go ahead and we want to take the derivative of s. So I'll take the derivative, and this gives us as s prime is equal to 2y minus 2. And I want to set this equal to 0 to find our critical numbers. Where could our max and our min live? Okay, and what we get is y is equal to 1. So if I have a number line, okay, of s prime here, and here is my endpoints, 0 and 30, and then here is my critical number, which is 1. Okay, I want to know, is this a max? Is this a min? So we're going to go ahead, we're going to test. Okay, so I don't have many options here. I'll test 1/2. Okay, and if I plug in 1/2 into 2y minus 2, right? This is s prime. Okay, this gives me 1 minus 2, which is -1. So this is negative. And then over here, I'll pick a nice solid number like 2, right? It's on that side. Okay, and that gives us 2 times 2, which is my favorite number, 4 minus 2, which is 2. Hey, it's positive. We're positive over there. So our function is decreasing from 0 to 1, and then increasing from 1 to 30. So what do we want? Do we want a max or a min? We want a maximum. Okay, so a max. Well, it's not in the middle, right? At our critical number, that's a minimum. This is a min. So it's got to be one of our endpoints. So what we'll do is we will evaluate s, our function s, okay, at these two values, at 0 and at 30. and we'll see what we get. So if I plug in 0 for my function, we get 60. If I plug in 30 for my function, whoa, much bigger, we get 30 squared, which is 900, minus 2 times y, which is 60, plus 60, so we get 900. Okay. So we want a maximum. So that's looking like at 30. All right, so what is our conclusion? Well, we can say, so note, right, that y is 30. That's where it's maximized. And if y is 30, then what does that make x? Well, I know that x plus y must equal 30. So if y is 30, then that makes x equal to 0. Okay, so our conclusion is the first number is 0, and the second number is 30. Done. What if this problem said find the minimum? Well, where's our minimum? It's when y is equal to 1. Okay, if y is equal to 1, what must x be? X must be 29. Okay, and then we could test this, right? I can plug in s of 1, and s of 1 would give us 59, right? So that's less than the others. Okay, so this would be the minimum of this function if it asked for it. Okay, all right, so that is it for this lesson. Thanks for watching. Catch you next time. Peace.